That's right. So Janet and Jessica and Kanani came down Friday, and this lava right behind me here was not here. So since Friday, and today is Tuesday, the lava flow has widened a little bit, and a new finger of lava has come down from upslope and spread out the road a little bit. What you remember from when the lava first crossed the road on July 25th is that it came across as a bit of a sheet of very fluid pahoehoe, only a few tens of inches thick. And then over time, as we know pahoehoe flows do, it has inflated and thickened, just like a souffle. And so behind me now, if you look towards where the road grade was, the lava is 2 or 3 meters thick at that point. So it's inflated since it first crossed the road. And that's a common phenomenon at pahoehoe we see again and again. And in fact, along the drive out here today, we were driving through a cross-section of a pahoehoe lava flow field, and you could see these beautiful inflation features in cross-section. So actually, it's an amazing geologic journey to drive this road and look at the lava flow in cross-section. Well, you certainly can stand on this if you wish. I certainly wouldn't recommend doing it in anything other than solid boots with a good lugged sole, because it is still hot enough that potentially standing on it with sneakers for any length of time, you could melt your sole and then be in a world of hurt. But the lava flow is still quite hot. I can feel the heat radiating behind me, and in fact, just about 10 or 15 meters to that direction, I still see glow in the cracks. So the lava is still very, very hot in its interior, and therefore to walk on it is to just expose yourself to a lot of radiant heat, as well as the hazard of falling. As you can see, the surface is extremely glassy. There are flakes of basaltic glass that are popping up off the surface, and as Janet said earlier, just a simple fall and catching yourself on your hand, you'll do a number on your skin. When the lava is flowing and you're seeing moving red lava, at that point it's probably around 1150 degrees centigrade, so that's close to about 2000 degrees Fahrenheit. It's very hot. Anything touching that lava would burst into flame pretty instantaneously. And as Jessica described, your body gives you the warning mechanism long before you get that close that you are getting too close to a very hot substance, and you will tend to back off. But that's one reason we wear long sleeves and pants to cover up all our exposed skin. And when in fact we are upslope closer to the vent and the HVO scientists are taking a sample of the lava, because one of the things we try to do is track the changing chemistry of the eruption, we have to completely cover ourselves, we wear a face mask, and get close enough to be able to actually sample the lava. I remember in 1986 when lava first hit the ocean, and what a magical experience that was to just watch that phenomenon of seeing molten rock, 2000 degree rock, hitting the cold ocean, and watching that interaction and seeing the processes unfold. As a scientist, there is so much to learn and study from that phenomenon, and of course that's incredibly compelling, but just as a human being, seeing that magical interaction of powers in nature was really, really remarkable. So to be back here and see this again is very meaningful personally, and I'm certainly thrilled that so many people can experience this now again because of this access through the emergency access road and that sort of thing. But from the perspective of the Hawaiian Volcano Observatory, we're concerned about the hazards down here, and we are part of the community of federal, state, and local agencies trying to help keep people safe. So we take seriously our job to keep track of the lava flow and update the maps of where lava is actually moving and where it's been. And this helps us decide sort of what the comfort zone, what the safety zone should be, and we work with the National Park Service to talk about that, to figure out really how close people should not be getting. In addition, there's still some basic science questions we're trying to answer about this eruption and the way lava flows behave. You might think after watching lava from Pu'uo'o for 33 years we'd know everything, but we don't. So for instance, this lava flow 61G gave us a great opportunity to study the development of a pahoehoe lava flow field over the course of a couple of months. So when the lava flow looked like it was getting serious and heading southeast from Pu'uo'o, we did a couple of things. With Park Service and other permission, we deployed a bunch of photo targets out around the projected path of the flow. And then we proceeded to twice a week fly in a helicopter over the evolving flow field and take careful photographic images as well as careful thermal images of that lava flow. With that information, we were able to do a couple of things. We were able to watch the expansion of the lava flow field in great detail by looking at where the hot material was, and that basically allowed us to map the advancing active lava. And then with those photographic images, we'll be working with some University of Hawaii Manoa colleagues to generate very careful digital elevation maps, so three-dimensional models of the lava flow field from week to week to week. And we did that until it hit the ocean. So we've got this great data set that will, I think, give us a lot of information about how much lava was feeding this flow and how that may have influenced how fast it went, how it widened, and other characteristics of its advance. The reason we stopped doing that careful analysis once it hit the ocean is that once lava is pouring into the sea, we kind of lose track of it. And as Janet described, this process of comminution and mechanical disintegration at the ocean, we suddenly have trouble tracking the volume that's going offshore. So that careful data set becomes a little more difficult to acquire. But we'll be working up those data in the coming months, and I'm very excited to see what we learn. One thing we didn't mention before, but I want to make sure you see, is that it's a great view today. The lava behind me has traveled just about 11 kilometers, just under 7 miles from the Pu'u'o vent. And that line of fume sources going up the Pali there along the park boundary and the Royal Garden subdivision boundary is marking the passage of the lava underground in the lava tube system. So certainly the helicopter folks are getting a good view as they fly up that lava tube of the different point sources where the fume is emerging from the lava tube. We're definitely making progress. I think we are gaining insight, and this steepest line of descent, the steepest line of descent path graphic that has been shared actually is a very good first order clue to where the lava is going to go. In fact, this 61G went right where we thought it would go based on the steepest line of descent. But I think this more careful analysis of the flow field development using these new data sets will give us some insights that will hopefully allow us in the future to predict more quantitatively both the rate and the eventual footprint of lava.
That's amazing.
Yeah.
That's got to make you guys feel good.
Yeah, well, we realize this is one of the most important questions that emergency management wants to know, and certainly the public who's affected. Well, certainly the accessibility is a marvelous attractant for visitors who want to see what an active lava volcano is doing, or an active volcano is doing. But from a scientific perspective, Kilauea has always been a marvelous laboratory for studying how volcanoes work. Many of the tools that are used worldwide now to monitor and study volcanoes were developed here in the early part of the 1900s because Kilauea was so active and so accessible. And so that continues today. In fact, HVO scientists and many collaborators from around the world are coming here and to the summit region to develop new techniques to study and understand how lava behaves, how volcanoes degas, how lava lakes behave, all these kinds of things. So that is one of the marvelous gifts that Kilauea and all the Hawaiian volcanoes give us, is that accessibility and that level of activity. The duration of lava flow entries. I know that since the Pu'u'o eruption began in 1983, just about half of the time of those 33 years and now change, we've had lava flowing into the sea. So for the recent past, the last few decades, it's really not that unusual. Long term, of course, that's how these volcanoes have grown. They've extended the coastline, and so it's not geologically unusual for the Hawaiian volcanoes. Worldwide, there are some volcanoes that have been putting lava into the ocean at Stromboli, in the Azores. I'm sure I'm forgetting some places. So there are other volcanoes where this process is happening, but many of them are not quite as accessible to scientists as this one.